What is a diffraction?
Light or other wave bends around the edge of the hole, through a narrow slit, or around a small object.
What is the principle of equivalence?
A central tenet of Einstein's general theory of relativity. The laws of physics in an accelerating reference frame or a gravitating frame are indistinguishable. You can't tell the difference between falling or being acted on by gravity. Requires that inertial mass equals gravitational mass.
What is a proton?
Positively charged particle in nucleus.
What is a third-class lever?
Simple machine with pivot at one end or bar, the effort force exerted at the other end. The input force between the two, ma less than 1.
How do the speed and position of a dropped object vary with time?
As long as the only force is the gravitational force. Then the acceleration is the acceleration due to gravity, g. At Earth's surface the value is 9.8 meters per square second. In the English system g equals 32.2 feet/s2. If the object is dropped from rest at time t equals 0, then the velocity at a future time t is simply v equals gt. That is, the velocity increases by 9.8 m/s each second. If we measure the distance fallen from the position where it was dropped, then at time t it has fallen a distance d equals 1/2 gt2. The following table shows velocity and distance fallen for some selected times.
What is an elastic deformation?
When the deforming force is no longer applied, object returns to its original shape. See plastic deformation.
What are very high frequency, VHF, waves?
Frequency 30 MHz 300 MHz.
What is a quark?
Particles that make up protons and neutrons and other short-lived particles. Fractionally charged, that is their charges are either 2/3 or 1/3 the charge of the proton and are called up and down respectively.
What is a vector quantity?
A quantity that has both a magnitude and a direction.
What is a Faraday cage?
Cage or metal grating that can shield electrical charge by gathering charges on outer shell of the cage.
What is a generation, ng, cell phone?
One G analog voice phone calls. 2G digital signals with more simultaneous users. 3G able to receive television-like video, video images, 4G very high-speed networks.
Could antimatter destroy the Vatican?
In Dan Brown's novel Angels and Demons, physicists at CERN use the LHC, the Large Hadron Collider, to produce 1/4 gram of antimatter. The material was stolen in order to destroy the Vatican. It is true that if 1/4 gram of antimatter were to completely annihilate with 1/4 gram of matter, the amount of energy produced would equal that of the bomb that destroyed Hiroshima. But, in over 10 years of experimental production, only 10 million antiprotons have been trapped and stored for times ranging from seconds to months. 1/4 gram is 1016 times as many antiprotons. Further, the antiprotons must be stored in extremely cold. Totally, antiprotons are created in accelerators, where the accelerated particle is slammed into a metal target, emitting gammas that create, in this case, proton-antiproton pairs.
What is a simple machine?
Device that matches human capabilities to do work to tasks that need to be done. There are 4 major groups: the lever, the wheel and axle, the pulley, and the inclined plane.
How can resonance cause crystal glasses to break?
Many years ago, Ella Fitzgerald performed a physics experiment in an advertisement for Memorex, R. audio tape cassettes. The company claimed that the famous singer could create a pure tone at just the right frequency to cause a crystal wine glass to break, and that the Memorex, R. tapes recorded and played back sounds so accurately that the glass would break both when Ms. Fitzgerald sang and when the recorded sound was played. Is it live or is it Memorex, R? was the advertising question. Although it is hard to think that glass is something that can bend. If you tap the rim of a thin wine glass, you can hear it ping. The shape of the rim of the glass oscillates. When the amplified sound waves pushed on the glass, it distorted its shape. Some of the kinetic energy in the sound wave was transferred into the kinetic energy of the oscillating glass. When the frequency of the sound wave matched the natural frequency of the glass, the amplitude of oscillation was large enough to shatter the glass. Sound can make glass break when amplified because the sound waves can cause the glass to oscillate and bend. When enough kinetic energy is used, the sound waves can distort the glass to the point where it cracks or shatters.
What is the zeroth law of thermodynamics?
The zeroth law is so obvious that it wasn't added as a law until after laws 1 through 3 were developed. It is based on thermal equilibrium between two bodies. As has been stated, if two objects have different temperatures, heat will flow from the hotter to the colder. If there is no temperature difference, there is no net heat flow. They will be in thermal equilibrium. The zeroth law states that if objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium. Suppose object B is a thermometer. You put it in contact with object A. Heat flows until they are at the same temperature. You then move the temperature to object C. If the thermometer shows no change, then B and C are in equilibrium and we can conclude that objects A and C are at the same temperature.
What is a second-class lever?
Simple machine with effort force exerted at one end or bar. The input force applied at the other end, and the pivot between the two. Ma less than, equal to, or greater than 1.
Where are AM and FM broadcasts found in the electromagnetic spectrum?
In the United States, commercial AM stations broadcast between 550 kHz and 1600 kHz. Commercial FM stations broadcast between 88 MHz and 108 MHz. In the AM band, the frequencies of stations are spaced by only 10 kHz. As a result, the broadcasts are limited to sound frequencies up to only 4 kHz. While the ear can detect frequencies as high as 15 kHz.
How much does a sound's intensity diminish as you move away?
When the total energy in the sound wave remains the same as the sound spreads over a sphere, the intensity decreases as the area of the sphere increases. The area of a sphere is proportional to the square of its radius. So the intensity is inversely proportional to the square of the distance. That is, sound intensity diminishes according to the inverse square law. For example, if a person stands 1 meter, 3.3 feet, away from a source, the sound intensity might be an arbitrary unit of 1. If that same person moved so she was 2 meters, 6.6 feet, away from the source, the intensity would be 1 over the square of the distance, or again 1/4 the intensity. Again, if the listener moved 3 meters, 9.8 feet, away, the intensity would be 1/9 it was at the 1 meter mark.
What is a fluid?
Solids retain their shape because strong forces hold the atoms in their places. In a liquid the forces keep the atoms close together, but they are free to move. In a gas the atoms are about 10 times further apart than in either solids or liquids, and forces between them are very weak. As a result of weaker forces, a liquid or gas can flow freely and assume the shape of their container. They are called fluids. There are two main areas of fluid study. The field that studies fluids in a state of rest is called static fluids. And the field that analyzes the movement of fluids is called fluid dynamics. We will first explore static fluids.
What is psychoacoustics?
Psychoacoustics, which connects acoustics with psychology, is the study of how the mind reacts to different sounds. This field of study is especially important to consumer product manufacturing, because a consumer associates particular sounds with certain products or sensations. For example, people associate low-frequency rumbling sounds with power and torque, while higher frequency sounds often represent high speeds and out-of-control occurrences. Psychoacoustics can play a major role in the development and commercial success of many products.
What is a solid?
State of matter. Solids retain their shape because strong forces hold the atoms in their places.
What is an electric field?
Region that surrounds a charged object. Another charged object placed in that field will experience a force.
What are ultrasonic sounds?
Ultrasonic sounds are those frequencies above human hearing. Frequencies above 20,000 Hz are not heard by people. but are heard by those animals whose hearing is sensitive to ultrasonic frequencies. For example, dolphins use ultrasonic frequencies to communicate. And bats use ultrasonic sounds as a tool for navigation and hunting.
Can fusion be used for peaceful purposes?
The energy released in a fusion reaction could be captured and converted into electrical energy. The difficulty in creating a fusion reactor is confining the reactants. Typically deuterium and tritium nuclei, at temperatures needed for fusion. There are two approaches, magnetic and inertial confinement. Most effort has gone into magnetic confinement where the positively charged nuclei are trapped in evacuated regions containing strong magnetic fields that keep the nuclei from colliding with the metallic walls of the equipment. The swarms of charged nuclei, a plasma, must then be raised to very high temperatures and held at that temperature long enough for fusion to take place. So there are three variables: number of nuclei, their energy or temperature, and the confinement time. The product of these three variables determines whether or not fusion will occur.
What is weight?
Force of gravity on an object, F equals mg.
Where did Newton study?
Newton was encouraged by his mother to become a farmer. But his uncle saw the talent Newton had for science and math and helped him enroll in Trinity College in Cambridge. Newton spent 4 years there, but he returned to his hometown of Woolsthorpe to flee the spread of the Black Plague in 1665. During the 2 years that he spent studying in Woolsthorpe, Newton made his most notable developments of calculus, gravitation, and optics.
What is a continuous spectrum?
Light of all wavelengths within a range produced by a hot solid or a hot, dense gas.
What is electrostatics?
Electrostatics is the study of the causes of the attractive and repulsive forces that result when objects made of two different materials are rubbed together. Electrostatics is the study of what is often called static electricity.
What is the principle of relativity?
The laws of physics are the same in two coordinate systems, moving at constant velocity with respect to each other.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
Does the gravitational force also obey Newton's third law? How?
All objects have gravitational fields surrounding them. So, just as the Moon has a force exerted on it due to Earth's gravitational field, Earth has a force on it due to the Moon's field. As a result, the Moon does not orbit around Earth's center. But the Moon and Earth orbit around a point roughly 2,900 kilometers from Earth's center. The Sun and other planets also exert gravitational forces on Earth, and Earth does on them. The gravitational fields of the planets, in particular Jupiter, cause the Sun to orbit around a point near its surface. Thus, if an observer on another planetary system studied the motion of the Sun carefully, he or she could determine that planets were orbiting the Sun. This method has been used to detect well over 200 planets, called exoplanets, or planetary systems, and other stars.
What is the history of electricity?
Prehistoric people valued and traded amber, a gem-like material that is petrified tree sap. Surely more than once a person would have rubbed amber on his or her fur clothing and noticed that fur was attracted to the stone. Perhaps she rubbed it hard enough to produce sparks. The Greek philosopher Thales of Miletus wrote about these effects around 600 BCE. But it wasn't until 1600 CE, some 2,200 years later, that William Gilbert, 1544 to 1603, an English physician, named this effect electricity after the Greek name for ember, electron. Gilbert showed that sulfur, wax, glass, and other materials behaved the same way as amber. He invented the first instrument to detect what we now call the electrical charge on objects, called a versorium, a pointer that was attracted to charged object. Gilbert also discovered that a heated body lost its charge, and that moisture prevented the charging of all bodies. In 1729, the English scientist Stephen Gray, 1666 to 1736, determined that charge, or what he called the electric virtue, could be transmit over long distances by metals, objects that couldn't be charged.
What is a resistance, R?
Friction that electrons encounter due to collisions with the atoms in a wire causes electric charges to lose electrical energy, equal to potential difference divided by current.
How were the details of the strong force determined?
Examining the kinds of isotopes that exist gives clues about the nature of the strong force. The most stable nucleus, helium-4, has 2 neutrons having spins in opposite directions and 2 protons also having spins in opposite directions. A majority of non-radioactive isotopes have even numbers of neutrons and even number of protons, allowing them to form pairs with opposite spins. Most of the other isotopes have either an even number of protons and an odd number of neutrons or the opposite. Isotopes with both an odd number of protons and neutrons are extremely rare. So, the strength of the strong force clearly depends on the spins of the nucleons. The mass of a nucleus is less than the sum of the masses of the protons plus the sum of masses of the neutrons. The larger the mass difference, the stronger the forces holding the nucleus together and the more energy needed to pull the nucleus apart. Studies of the mass of the nuclei can thus be used to gain further insight into the strong force. Maria Geppert-Meyer, 1906–1972, was a German-born American physicist who explained why nuclei with certain numbers of protons and / or neutrons, called magic numbers, were extremely stable. Her theory showed that the nuclear force depended on both the spin of the nucleon and its orbital angular momentum. The magic numbers are 2, 8, 20, 28, 50, 82, and 126. Thus helium-4, the most stable nucleus, has a magic number of protons and a magic number of neutrons, and so is called doubly magic. Oxygen 16, calcium 40, and calcium 48, and lead 208, which is the heaviest stable nuclide, are also doubly magic. But, are all nuclei stable? What rays do radioactive materials emit? Among the scientists who explored radioactivity immediately after Becquerel's discovery was Ernst Rutherford, then at McGill University in Montreal, Canada. He and Frederick Soddy found that uranium and thorium emitted 2 different kinds of rays. One could be stopped by paper, the other required metal about a centimeter thick. Rutherford named them alpha and beta rays after the first 2 letters in the Greek alphabet. In 1907 he named the even more penetrating rays produced by radium gamma rays. In 1900 Pierre, 1859–1906, and Marie Curie, 1867–1934, using an electroscope, found that beta rays are negative particles. Becquerel used the same kind of apparatus J. Thomson, 1856–1940, had used. See the chapter What is the World Made of? To measure the ratio of mass to charge of an electron to determine that betas typically travel at about half the speed of light and are identical to electrons. In late 1907 Rutherford demonstrated that alpha rays were helium atoms with the 2 electrons removed. He had not yet discovered the nucleus. Today we say that an alpha particle is the helium-4 nucleus. Gamma rays were later found to be very high-energy photons.
What is the difference between a dead load and a live load?
In order to remain static, bridges, and all structures, for that matter, must be able to withstand loads placed on them. A load is simply the engineering term for force. Dead load is the weight of the bridge or structure itself. The live load, on the other hand, is the weight and forces applied to the bridge. As a result of the vehicles and people that move across the bridge at any one time. Of course, in order to be safe, engineers account for much higher live loads than would normally occur.
How are the results of collisions in accelerators detected?
A collision between two protons or a proton and antiproton can produce a large number of particles of different kinds. The task of a detector is to find the direction in which each particle is going, find its charge, momentum, and energy, and identify it. Detectors are huge devices. The CDF Collider detector at Fermilab weighs 5,000 tons and is 12 meters, 39 feet, in each dimension. It is operated by a collaboration of about 600 physicists from 60 universities and organizations. Atlas, a toroidal LHC apparatus, at LHC is even larger. It weighs 7,000 tons, is 44 meters, 144 feet, long and 25 meters, 82 feet. In diameter, 2,000 physicists are involved in building and operating this experiment. In both detectors, position detectors locate the particles close to where they are produced in the beam line. Somewhat farther away from the beam line, a strong magnet deflects the paths of charged particles. Outside the magnet are additional position detectors and finally detectors that measure the energy of the particles. The curved paths charged particles take in the magnet are used to find their charge and momentum. Each collision can produce billions of pieces of data, only a small number of which are interesting. Electronic circuits and fast computers use data from the position detectors to decide whether the set of data are interesting enough to be recorded. Atlas produces 100 megabytes of data each second. The entire LHC produces 4 gigabytes of data each second. Enough to fill a DVD disc. Up and down respectively. The proton is composed of 2 up quarks and 1 down quark, while the neutron is composed of 1 up and 2 down quarks. You can check to see that the charges of the quarks add up correctly. Up and down quarks are said to be 2 different quark flavors. Because the quarks have half-integral spin, like electrons and neutrinos. There cannot be 2 identical quarks that have the same quantum properties. Quarks have additional property called color charge that can be red, green, or blue. A proton or neutron must have quarks with one of each of the colors so that they add to white. Just like ordinary colors do.
What is mass energy?
Potential energy, the result of the mass of an object first postulated by Einstein.
What is the latest fusion reactor research project?
The ITER reactor project is international in scope, including the United States, Russia, the European Union, India, Japan, China, and South Korea. The plan is to spend 10 years in construction and 20 years in operation. No electrical energy would be generated. That would require a more advanced reactor. Using 0.5 grams of deuterium-tritium fuel. It is designed to produce 500 megawatts of energy over 1000 seconds. For the first time in a fusion reactor, more energy would be produced than needed to run the reactor. In May 2010, contracts were signed to construct the first buildings in the project that are sited in the south of France. Fusion reactions are scheduled to begin in 2018.
What class lever is a can or bottle opener?
Locate the pivot point and compare to the 3 drawings above. Your forearm is a lever, with the elbow joint being the pivot.
How did Luigi Galvani's experiments lead to the development of current electricity?
Galvani believed that the flow of charge from the nerve into the muscle caused the contractions. His fellow scientist at the University of Bologna, Alessandro Volta, 1745–1807, recognized that Galvani's frog leg was both a conductor and a detector of electricity. In 1791 he replaced the leg with paper soaked in salt water, a conductor, and used another means of detecting the electricity. He found that charges flowed only if the two metals touching the paper were different. The combination of two different metals separated by a conducting solution is called a galvanic cell after Galvani. Volta went further. He found that the two metals that produced the greatest electrical effect were zinc and silver. In 1800 he stacked alternating discs of zinc and silver, separated by a card wetted with salt water. He found that this device, called the voltaic pile, was a continuous source of charge flow. Sir Humphrey Davy showed that the charge flow was due to a chemical reaction between the metals and the conductive solution in the cards.
What is resonance and how can it be achieved?
All objects that can vibrate have a natural frequency of oscillation. If you hold one end of a ruler on a desk and push down and then suddenly release the other end, you will see it vibrate. The natural frequency depends on the material and its width, thickness, and length. Resonance occurs when an external oscillating force is exerted on an object that can vibrate. When the frequency of the external force equals the natural frequency, then the amplitude of the oscillation reaches a maximum. This condition is called resonance. A very small external force is needed to create a large oscillation amplitude. You can explore resonance with a mass, like a yo-yo or a heavy metal washer on a string. Hold the top of the string still and pull the object to one side and watch it oscillate at its natural frequency. Then shake the top of the string at the same frequency and watch the amplitude of the oscillation increase. You will have found the resonance frequency. If you raise or lower the shaking frequency, you'll find that the amplitude of the oscillation is smaller.
Does the total energy of a system ever change?
No. Think about a block of wood on a table. You push it, doing work on the block and transferring energy from your body to the block. The block starts moving, but quickly slows and comes to a stop.
How are magnetic materials used in computers?
Magnets are used in the compact motors that turn the discs in the CD or DVD drive and that move the laser that reads the disc to the correct position. Motors rotate the discs in a hard drive. The arm on which the read/write head is mounted is rotated to the correct portion of the hard drive. Disk has a coil of wire on it in a magnetic field. When there is a current through the wire, the force moves the arm to the correct position. The disc itself is often made of aluminum coated with an extremely thin 10 to 20 nanometers film of magnetic material that is divided into submicrometer thick regions that are perpendicular to the surface of the disc. Each region is magnetized one way to represent a 1 and another way to represent at 0. A tiny coil in the read/write head carries the current that magnetizes the regions.
What is a decibel?
A decibel, dB, is the internationally adopted unit for the relative intensity of sound. The sound intensity of 0 decibel is the threshold of human hearing. 1016 watts/cm2. This corresponds to a pressure of 2 x 10⁵ newtons/m2 or 2 billionths of atmospheric pressure. The ear is extremely sensitive. The decibel scale is a logarithmic scale, meaning for every 10 decibels, the intensity is increased by a factor of 10. For example, a change from 30 decibels to 40 decibels means the sound will be 10 times more intense. A change from 30 decibels to 50 decibels would mean the new sound would be 100 times more intense. The following chart shows a typical sound environment, how many times louder those levels are than the threshold of human hearing, and the relative intensity of that sound compared to the threshold of hearing.
When were lenses first made?
The word lens comes from the name of the lentil bean because of the similarity in shape of the bean and a converging lens. Lenses have been used for over 3,000 years. It's possible that ancient Assyrians used them as a burning glass to start fires. A burning glass is mentioned in a play by Aristophanes written in 424 BCE. Roman emperors used corrective lenses and knew that glass globes filled with water were able to produce magnified images. Al-Haytham Al-Hazan, 965-1038 CE, wrote the first major textbook on optics. That was translated into Latin in the 12th century and influenced European scientists. Shortly thereafter, in the 1280s, eyeglasses were used in Italy. The use of diverging lenses to correct nearsightedness, myopia, was documented in 1451. Today, lenses used in eyeglasses and cameras are usually made of lightweight plastics that are cheaper and more durable than traditional glass lenses.
What happens if you look at a mirror while lying down?
Now left and right are not reversed. Your chin is on the same side of both you and your image. But if your right eye was higher than your left, then in the image the left eye will be higher.
How do refrigerators and air conditioners work?
As you know, when a liquid evaporates into a gas, it is cooled. Heat flows into the system. The opposite process. The condensation of a gas into a liquid results in an increase in thermal energy and an output of heat. A refrigerator circulates a refrigerant, a liquid that evaporates at a low temperature. Through tubing, the gas is compressed by an electrically driven compressor. The pressure and temperature of the gas increases. Coils of the tubing outside the refrigerator cool the liquid and heat the air around them. As it cools, the refrigerant condenses back to a liquid that goes through a tiny hole, called the expansion valve. The pressure drops, evaporating the liquid, making the gas cold. The tubing containing the cold gas is in the inside of the refrigerator, making it cold, and cooling the food. An air conditioner works in a similar way. The evaporator is in the unit inside the house and the compressor is outside. Because of the work put into the compressor, heat is removed from the air inside the house and transferred to the outside air. The diagram below shows work and heat flows in a refrigerator or air conditioner. The first home refrigerators used ammonia as a refrigerant, but ammonia is toxic. In the 1930s, Freon was first developed by the DuPont Company of Wilmington, Delaware. Freon is a chlorofluorocarbon, CFC. If freon escapes, it carries chlorine atoms to the upper atmosphere. Their ultraviolet radiation from the sun separates one of the chlorine atoms from the CFC. That atom converts ozone back to oxygen, contributing to the destruction of the ozone layer. An essential barrier against harmful ultraviolet sunlight. Freon's destructive nature has been known since the 1970s, but it was not until the early 1990s that legislation was implemented banning the use of freon in new air conditioners and refrigerators. It has been estimated that in 2002 there was 6 million tons of freon in existing products. Unfortunately, when the chlorine destroys an ozone molecule, the chlorine is not destroyed, but instead continues to live for a while, destroying more ozone. In fact, more freon is still headed toward the upper limits of the atmosphere. For it can take several years for freon to reach such elevations. DuPont and other corporations have developed replacements for freon that replace the chlorine atoms with hydrogen atoms. These substances do not harm the ozone layer and are in use in refrigerators, air conditioners, and aerosol cans.
Why is noise pollution dangerous?
In the past, noise pollution was only thought to create health effects if the intensity was large enough to cause hearing damage. Studies over the past several decades, however, have found that long-term exposure to noise can cause potentially severe health problems in addition to hearing loss, especially for young children. Constant levels of noise, even at low levels, can be enough to cause stress, which can lead to high blood pressure, insomnia, psychiatric problems, and can even impact memory and thinking skills in children. In a German study, scientists found that children living near the Munich airport had higher levels of stress, which impaired their ability to learn, while children living further from the airport did not seem to experience the same problem.
What is a Bose-Einstein condensate?
Quantum effects on a macroscopic scale exhibited by extremely cold gas of atoms. Boson particles like photons and gluons with integral spin.
What is a gamma ray?
High-energy photons emitted by some radioactive nuclei.
What is the optimal shape of a concert hall?
Building a concert hall is a mixture of science, engineering, art, and politics. Politics is important because the people who provide the funds have goals for the use of the hall. Consider, for example, the history of Philharmonic Hall in Lincoln Center, New York City. It was originally designed to be similar to the Boston Symphony Hall, long and narrow. But, a campaign led by one of the major newspapers in the city argued that the hall should seat more than 2,400 people, and so the architects made the hall wider. But when it was completed in 1962, critics were very unhappy with the sound. The wider hall did not have enough initial reflections and sounded dry. It was equipped with clouds, reflectors hung from the ceiling. But reflections from them were too delayed to be effective. Another problem was that performers on the stage couldn't hear each other.
What if the tool or appliance has a 3-prong plug but you have only 2 slot outlets?
Do not use the appliance if you do not have the proper outlet for the device. Cutting off the grounding prong will defeat the safety feature of the separate ground wire.
How else is friction useful in accelerating things? How do you walk or run?
Your feet are also interacting with the ground. As long as there is sufficient friction, when you push your feet backwards, the ground pushes you forward.
Where are the best surfing beaches?
The best surfing beaches are located along the edges of oceans. When wind conditions have produced waves with large wavelengths. Another requirement of a good surfing beach is a gradual decrease in water depth.
What is the maximum decibel level that a person can experience without pain?
The threshold of pain for humans depends on the person in question, but typically ranges between 120 decibels and 130 decibels. Such pain can be experienced at extremely loud rock concerts, and next to jet engines and jackhammers, for example.
Who really discovered oxygen?
Three scientists are often credited with the discovery of oxygen: Carl Wilhelm Scheele, Antoine Laurent de Lavoisier, and Joseph Priestley. The Swedish scientist Scheele discovered what he called fire air in 1772. The name came from the way an ember would burst into flame when immersed in the gas. Scheele wrote a book describing his work, but it took 4 years to be published. In the meantime, Priestley in 1774 discovered what he called dephlogisticated air. Lavoisier, who met Priestley in 1774 and was told about Priestley's discovery. Claimed to have discovered what he called vital air. Although he was sent letters from both Scheele and Priestley describing their earlier work, he never acknowledged their receipt. Lavoisier's great contribution was to make precise studies of the role of oxygen in a variety of reactions and to give it the name oxygen.
What is an opaque material?
An opaque object is something that allows no light through it. Concrete, wood, and metal are some examples of opaque materials. Some materials can be opaque to light, but not to other types of electromagnetic waves. For example, wood does not allow visible light to pass through it, but will allow other types of electromagnetic waves, such as microwaves and radio waves, to pass. The physical characteristics of the material determine what type of electromagnetic waves will and will not pass through it.
What are some ways of transferring thermal energy?
Heat is the transfer of energy from a warmer to a cooler object. The transfer can occur by two different processes. If the hot object is in contact with a cooler one, the process is called conduction. The faster molecules in the hotter object strike the slower ones in the cooler one, transferring their thermal energy. The average speed, and thus kinetic energy of the molecules in the warmer object are reduced, while those in the cooler object are increased. If the warm object is in contact with air or water, it heats the fluid. Hotter fluid has a lower density, and so it rises. Its place is taken by colder fluid, creating moving currents of the fluid, called convection currents. Convection is a very efficient way of transferring energy from hot to cold objects. The thermal energy can also be transferred even if the warmer object isn't in contact with any other object. The vibrations of the molecules create infrared electromagnetic waves that carry energy. These waves are called radiation. The warmer the object, the more energy in the waves. More energy goes from the warmer to the cooler object than in the reverse direction. So radiation cools the warmer object and warms the cooler one.
What are low-frequency, LF, waves?
Frequency 30 kHz 300 kHz.
What are the properties of magnets?
You've probably played with magnets since you were a child. It is likely that you found that magnets attract some materials but not others. You may have found that you can use a magnet to magnetize items like paper clips, nails, and screws. If you played with two magnets, you found that they could either attract or repel each other. Whether you played with metal bar-shaped magnets, rectangular or circular ceramic magnets, you found that the magnet exerted stronger forces at the ends or faces of the magnets. Those regions are called poles. If you hang the magnet from a string so it can rotate freely, you'll find the magnet orienting itself north to south. The end facing north is called the North Pole, the other the South. Like poles repel each other while unlike poles attract, but either end can attract other materials. Children often discover some of the properties of magnetism by playing with bar magnets and metal shavings. In this way, you can easily discover that magnets have opposite poles and create magnetic fields. Magnetic poles always come in north-south pairs called dipoles, two poles. Some theories predict the existence of isolated north or south poles, called monopoles. But, there have been extensive searches for monopoles over the past decades and none has ever been found.
What is nuclear physics?
Study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed.
What is the lowest possible temperature?
The lowest possible temperature is called absolute zero, 0 K. It is the temperature at which molecular motion is at a minimum and cannot be further reduced. While absolute zero can never be reached, see the third law of thermodynamics later in this chapter. The present record low temperature is 4.5 Nk, 4.5 billionths of a Kelvin.
What are shadows?
Shadows are areas of darkness created by an opaque object blocking light. Whether created when someone puts their hand in the light from a movie projector, stands outside in the sunshine, or sees the moon move between Earth and the sun during an eclipse, shadows have always intrigued us.
What is radio astronomy?
Uses VHF, UHF, and microwave portions of the electromagnetic spectrum to study planets, stars, and galaxies.
How do clouds form?
As warm air rises into the atmosphere through convection currents, the air expands as it experiences less atmospheric pressure. During the expansion, the warm water vapor quickly cools and condenses, forming water droplets in the air. When the droplets begin to accumulate, they attach themselves to dust particles in the air and form clouds.
What is the third law of thermodynamics?
Absolute zero can never be reached.
What allows nocturnal animals to see better in the dark than humans can?
There are three main reasons why some animals can see better than humans can at night. The first reason is that their eyes, relative to body size, are larger and can gather more light than human eyes can. More light results in a brighter image. The next reason has to do with the rods and cones in the nocturnal animal's eyes. Cones are used for detail and work best in bright light. A nocturnal animal has little need for the color vision provided by the cones and therefore has more room for the rods that detect general information such as motion and shapes. The third reason why nocturnal eyes excel in the absence of light is due to the tapetum lucidum, a membrane on the back of the retina that reflects light back to the retina to double the retina's exposure to light. The reflective tapetum can be seen in the light reflected back out of animals' eyes at night when you shine a flashlight on them.
What is radiation?
A means of heat transfer when infrared waves are emitted by hotter objects and absorbed by colder ones.
What is a precession?
The rotation of the axis of rotation of a rotating object due to a torque on the object.
What is a suspension bridge?
Bridge using cables from which wires are attached that suspend the roadbed.
If not against a wall, how can you stand on your toes?
You naturally move your arms forward or bend forward to move your center of gravity forward.
What is a rod?
Rod-shaped nerve cells on the retina that sensitive to low light levels. Responsible for a general image over a large area, but not fine details.
What is a monopole?
Isolated north or south poles. Predicted by some theories, but never found.
How does one become a physicist?
The first requirement to be a physicist is to have an inquisitive mind. Albert Einstein, 1879 to 1955, himself admitted, "I'm like a child. I always ask the simplest questions." It seems as though the simplest questions always appear to be the most difficult to answer. These days, becoming a physicist requires quite a bit of schooling along with that inquisitive mind. In high school, a strong academic background including mathematics, English, and science is necessary in order to enter college with a strong knowledge base. Once you are a physics major in college, you will take courses such as classical mechanics, electricity and magnetism, optics, thermodynamics, modern physics, and calculus in order to obtain a bachelor's degree. To become a research physicist, an advanced degree is required. This means attending graduate school, performing research, writing a thesis, and eventually obtaining a PhD, Doctor of Philosophy.
What is a very large array, VLA?
Group of 27 radio telescopes spaced as much as 13 miles apart from each other in Socorro, New Mexico.
Does momentum apply to objects that rotate?
Quantities that describe rotation are similar to, but different than, those that describe straight line motion. Position is replaced by angle, velocity by angular rotation. Acceleration by angular acceleration. Force is replaced by torque.
How can that be useful?
It's because the distance moved, output distance, is larger than what you move, input distance. And, therefore, the output speed is also greater. A baseball bat, tennis racket, and golf club can be considered simple machines in which high speed of the end of the implement is desired.
How does a pinhole camera work?
A pinhole camera is typically made from a box with a small pinhole in one side of the box and a screen on the other side. The pinhole is so small that only a very small number of light rays can go through it. The diagram on page 211 shows how a pinhole creates a reproduction of the object on the screen. Note that it is not an image because light rays do not converge on the screen. Pinhole cameras are easy to make and are often used during solar eclipses because it is very dangerous to look directly at the sun, during an eclipse or otherwise. With the sun at your back, point the hole up toward the sun and view the image of the moon passing in front of the sun on the screen.
How are gears used today?
In addition to automobiles and clocks, gears are used in washing machines, electric mixers, and can openers, and electric drills, as well as hard drives and CD/DVD drives in computers. Today much of the development of gears is associated with improvements in the materials used. New metal alloys increase the lifetime of gears used in automobiles and industries. Consumer electronics uses plastic gears that require no lubricant and are quiet.